So a little review from yesterday. Yesterday, we developed the quadratic formula. And the quadratic formula works like so. We got this thing where you can just plug in numbers to solve for x, but it only works, and that's why I wrote at the beginning, for ax squared plus bx plus c, equals 0. Forgot the equal sign. There we go. You have to have it in the form where it equals 0. Same with the zero product property. In order to factor and use the zero product property, it has to be equal to 0. So when you have a quadratic equation, often you want to have one side equal to 0. And then you have three choices. Should I factor? Should I complete the square? Or should I use the quadratic formula? And if a question like this just says solve, you can choose which method you want to use. Now, first of all, this looks really promising on the left side because it's already factored. But the problem on the right-hand side is it's not equal to 0. So since it's not equal to 0, the factored part actually doesn't help us whatsoever. And so we have to multiply this out. I would multiply all of these things out. My first ones will give me a 2x squared. My outside and my inside, you're going to get good at combining those. Minus 2x plus 1x will give me minus x, and 1 times minus 1 equals 5x. So it's a quadratic equation, and we're going to have to combine our like terms all on one side, so I'm going to subtract that 5x. How quickly can you check this to make sure that it can't be factored? Can you do the mental math? See, this one won't be factored. So then you're down to two options, completing the square or the quadratic formula. Someone in the other class said, how do you know, like, when would completing the square actually be a better method, a quicker method? Well, you'd have to divide by 2, right? So one of the things I'd look at is if I divide it by 2, do I get any fractions? Yes. So I probably would say I want to avoid it because the fractions, like we did in the warm-up, make it a little bit more difficult. Or, so I look at that, are there any fractions? Or would it be, if the middle number after dividing is odd, it's going to get fractions that way as well. So this one looks like it's a good choice for your quadratic formula. So you go to your quadratic formula. Your b value is -6, so negative b would be positive 6 plus or minus. Negative 6 squared is positive 36. Remember, when you square a negative number, it becomes positive. Minus 4, a is 2, c is -1 over 2a. Notice how I put the numbers in brackets when I substitute them in so that that -1 doesn't look like a subtract 1. And now we just have to simplify. 36 plus 8 is 44. All divided by 4. And that's the answer. But at this point, you would still lose marks on your quiz or test because it's not simplified. Can you see that you can simplify the square root? Because you can, it's 4 times 11, and the square root of 4 is 2, so it'll become 2 root 11. And now you would still lose a half mark if you stopped here. Because you're dividing by 4, well, both terms on the top don't divide by 4, but there is a number that everything divides by. Can you see that all 3 would divide by 2? So we need to simplify this one more time. Divide everything by 2. And there's our final answer. Everybody good? I'm going to scroll back up. Draw a line here. We'll do B right beside it. Now B, if I move over the 3 to make one side equal to 0, first of all, doesn't look very nice here for factoring the fractions. Doesn't look very nice for completing the square because of fractions. Doesn't look very nice for the quadratic formula because of fractions. The quadratic formula will work if you plug in fractions. However, you have an equation. And anytime you have an equation, if you want to, you can get rid of the fractions. Can you see a number I could multiply by to get rid of one fraction? What could I multiply to get rid of the half? I could multiply by 2. What could I get rid of to get rid of the 4? I could multiply by 4. Is there a number that you could multiply by that would get rid of both of them? Right? 2 would get rid of the 2, but it wouldn't get rid of the 4. Would 4 get rid of the 4 and the 2? Yes. So if I multiply both sides by 4, which distributing would multiply everything by 4, I would get 2x squared minus 5x minus 12 equals 0. And at this point, you now have 3 options. You could try factoring, you could try completing the square, or you could try the quadratic formula. You have to decide which one is best for you. Okay? Now, sometimes when there's a number out in front and then there's a 12, the numbers look kind of big, people might get a little bit leery, like, ooh, I could try factoring, but what happens if factoring doesn't work? Then I'd have to use the quadratic formula. If you use the quadratic formula, it'll actually tell you, there's a hint in the quadratic formula where it says, haha, you could have factored. But sometimes you're like, ooh, factoring takes thinking. The formula takes no thinking whatsoever. So what do you think students like to pick more of? The non-thinking option. So I'm going to tell you, this one can be factored. I'm going to leave brackets here. I'm going to split it up. We're going to factor it afterwards. But since you're students who like to choose that no thinking option more often, I'm going to show you how the quadratic formula shows you the answer. So let's go to the quadratic formula. Let's say negative b, well, that'll be 5 plus or minus square root of negative 5 squared is positive 25 minus 4, a is 2, c is negative 12 over 2 times 2. X equals 5 plus or minus, and this is going to be 24 times 4 is 96 plus 25, 121 over 4. And this, at this moment, your quadratic formula says, ha ha, you could have factored. That number is the hint that you could have factored. Why? Because it's a perfect square. Anytime the number after simplifying comes out to a perfect number where you can square root it easily, because what's the square root of 121? It's 11, so this becomes 5 plus or minus 11 over 4, which, if you did the plus, do you see that you would get 16 over 4? Which is just 4. If you did the minus, 5 minus 11 is negative 6. Negative 6 over 4 reduces to negative 3 over 2. There's your 2 answers with the quadratic formula. They're nice answers. And in fact, if I scroll up just a bit to where I was about to factor, I could write those, like, that should have been the same thing that I would have got had I factored. And you can actually really quickly factor this by cheating and using the answers. And what I mean by that is if you know one of the answers is x equals 4, what's the factor that would make x equals 4? Does that make sense? That if x equals 4 is the answer, then the factor had to have been x minus 4. Now we can do that just a little bit harder with the fraction, but you can also then, well, if you know this is x minus 4, and your first one's a 2x squared, you know that's a 2x. And if your last one's a minus 12 and this is a minus 4, you know that your last one would have to be a plus 3. Do a quick check. Does your outside and inside make minus 5? It does. So if your mental math for factoring gets really good, you can check them quickly, see if it can be factored. If you do a quick check and nothing seems to be working, go to your quadratic formula. And sometimes your quadratic formula is going to laugh at you and go, ha, you could have factored. But you're like, I don't care. I get the answers the same way anyways. And some people like to go to the quadratic formula right away and say, even if it factors, I know that it's going to work. And now you know a way, if a question says, solve by factoring, and you're stuck. On scrap paper, you could cheat and use the quadratic formula and figure it out, and then just go back to your test and pretend like you factored it. Just like we pretended like we factored it, but worked backwards. Is that technically cheating? I don't know. It's like kind of manipulating the system a little bit. But it's nice that you have a backup to be able to do that. Okay, lots of questions for practice. Circle all of them from 7 to 13.